Hello everyone. So today we are going to start chapter number 6, pipelining and superscalar techniques. This is again module 3, chapter number 6 in the textbook Kai Hong and Jotwani. Okay. So in this chapter we will learn about pipelining and superscalar techniques. So here we will learn linear pipeline processors, non-linear pipeline processors, instruction pipeline design, arithmetic pipeline design, and superscalar pipeline design. So first we will start with linear pipeline processors. So linear pipeline processor. So models of linear pipeline. Again we have two models, synchronous and asynchronous. And also we learn about the clock cycle, pipeline frequency, clock skewing, flow through delay, speed up, efficiency, and throughput. And finally we'll learn about optimal number of stages and performance cost ratio. So first we will start with linear pipeline processor. So linear pipeline processor is a linear pipeline processor is a cascade of processing stages which are linearly connected to perform a fixed function over a stream of data flowing from one end to another. So as the name itself suggests, so linear pipeline means it is a cascade of processing stages. So we'll get to know the definition when we see the diagram. So we are connecting different stages linearly, and so these linear pipelines can be applied for instruction execution, arithmetic computation, and memory access operations. So linear pipeline is constructed with k processing stages. So external inputs are fed into the pipeline at the first stage S1, and the process results of stage S1 are passed from stage S1 to Si to stage Si plus 1. Okay, suppose if it is stage S1, that is S1 to S1 plus 1 is S2. Okay, for I here it is equal to 1 to up to k minus 1, and the final result emerges from pipeline at the last stage Sn. So depending on the control of data flow, depending on the control of data flow along the pipeline, we model linear pipeline in two categories. One is asynchronous and synchronous. So once you see the diagram, you will easily understand what is asynchronous and synchronous model. So if you come here, so this is a diagram for asynchronous pipeline model, and this is the diagram for asynchronous pipeline model. Then we have a reservation table, so we will discuss each one by one. Okay, so this is a diagram for asynchronous model. So as shown in the figure, so the data flow between adjacent stages in an asynchronous pipeline is controlled by handshaking protocol. Okay, so what is a handshaking protocol means? When stage Si is ready to transmit, it sends a ready signal to stage Si plus 1. Okay, So when stage Si is ready to transmit, it sends a ready signal to stage Si plus 1. After stage receives the incoming data, it returns an acknowledgement signal to Si. So for example, if you see here, so here this is ready signal. Okay, so whenever S1 is ready to transmit, sends a ready signal, and it is sent to the next stage. So after this S2 receives the signals, okay, data, then it will send an acknowledgement so that it has received the data. So this is called as handshaking protocol. So asynchronous uh, pipelines are useful in designing communication channels in message passing multi-computers where a pipeline wormhole routing is practiced. Okay, so different amounts of delay may be experienced in different stages. If you observe here, the delay may be more in some stages. Okay, so asynchronous means every stage has a ready signal as well as an acknowledgement based on the input signal what it receives. Whenever it receives the data, so it will acknowledge it. So main thing is that this handshaking protocol. Okay, so next we will discuss about synchronous model. So synchronous pipelines are illustrated in the below figure, and clock latches are used to interface between the stages. If you observe here, we have a latches at after every stage. After S1 we have a latch, after S2 we have latch. So after every stage we have a latch. This is clock latch are used to interface between the stages. So latches are made with master slave flip-flops which can isolate inputs from outputs. Okay, so these are nothing but master slave flip-flops, and upon the arrival of clock pulse, all latches transfer data to the next stage simultaneously. So if you observe here, so whenever a clock cycle arrives, so whenever it is high, so simultaneously all the stages will transfer the data to the next stage. So the pipeline stages are combinational logic circuits. It is desired to have approximately equal delays in all stages. Okay, so we have equal delay in all stages, but in asynchronous delay is different for different stages. So this is a speed up factor for a speed up factor and optimal number of pipeline stages for a linear pipeline unit. Okay, so if you observe here, we have at y-axis we have a speed up factor, and this side we have a number of operations. So as the number of operations increases, like from 1 to 128 operations are there, so the number of stages also increases. Okay, so as the number of operations are more, then we have number of stages also more, and at the same time speed is also increased. Okay, so whenever for less operation, pipeline technique is not applicable. Okay, when one or two operations, speed of factor is also 2, so you will not achieve much speed of factor. So whenever we have more number of operations like 32 or 64, and then the speed of factor comes into picture, that is we have speed of factor around 10. Okay, and performance cost ratio, if you observe here, so we have number of stages, we are taking it as k. Okay, so optimal number of pipeline stages, if you observe here, so it is at peak here. Okay, so let us now discuss about non-linear pipeline processors, and here we will discuss about what is non-linear pipeline processors. So earlier we discussed about a linear pipeline processors. We will discuss now about dynamic pipeline or non-linear pipeline processors. Okay, so non-linear pipeline processors are also called as dynamic pipeline, can be reconfigured to perform variable functions at different times. So if you observe, traditional linear pipelines are static pipelines because they are used to perform fixed functions. So for variable type of functions, a linear pipeline is not suitable. Okay, and a dynamic pipeline allows feed forward and feedback connections in addition to the streamline connections. So in traditional linear pipelines, we didn't had any feed forward and feedback connections in addition to the streamline connections. So this is a three-stage pipeline, non-linear pipeline, and if you observe here, we have an input here and we have a S1, S2 and S3, all are connected, but also we have a feed forward as well as feedback connections also. If you observe S2 here, S2, so we have an output to S3, and also from S3 there is a feed backward connection is there, and from similarly if you observe from S1 also we have a feed forward connection, and if you observe from S3 we have feed backward connections. So these feed forward and feed backward connections are needed for dynamic connections, and this is a reservation table for function x and reservation table for function y, and here we see at stage S1 clock cycle 1 we are executing S1 and clock cycle 2 S2. So we don't have fixed number of so this is not linear in fashion. Okay, here also we are executing. So if you see, this function x is taking 8 clock cycles to execute, and this is taking 6 clock cycles to execute. This is a dynamic pipeline example with feed forward and a feedback connection for two different functions. Okay, so in this video we discussed about uh, linear pipeline processors. So linear pipeline processor is a cascade of processing stages which are linearly connected to perform a fixed function over a stream of data flowing from one end to another. So now we can easily write this statement by seeing the diagram. This is a linear, that is cascade connections of different stages of stages which are linearly connected, means they are connected linearly one after the another. So this is called as a linear pipeline processors. Okay, again we have two types. One is synchronous and asynchronous. So asynchronous, again, if you come here, so synchronous is using handshaking protocol, and after each stage have a ready as well as acknowledgement. So whenever stage S1 or stage Si is ready to transmit data, it will send ready signal to the next uh, stage, and after receiving the data from previous stage, it will send an acknowledgement back to the stage S1. So this is called as asynchronous, that is handshaking protocol. And in synchronous we are using latches. So in asynchronous we are not using latches. So in order to have uniform delays in the successive stages. Okay, similarly we have a non-linear pipeline with feed forward and feedback connections. Apart from linear connections, we also have extra connections to implement dynamic functions. So this is an example of reservation tables for two different functions, and it is taking different clock cycles for different functions. So it is dynamic in nature. Okay, thank you.